Hey guys, welcome back to Goggles Paisano's HO Scale Slot Car Racing channel on YouTube. Gonna do a little bit of a all over the place video today. We're gonna be talking about how the track was wired originally, how it's currently wired with modern technology, um, lap counting, how it was done back in the day, how it's wired up now, things that we could have gone with in the day in between, and just gonna have a good old time explaining it all. Some people have asked me on Facebook, on some of the group pages, on how I did things. Um, so hopefully this one's for you guys. So just you know, like, comment, subscribe if you want at the end, and we're just gonna go into it. Okay. Um, Back in the day, this track would have been powered by four of these Aurora model motoring DC power packs. These would have been between 18, 20, and 22 volts. I found them to be offering. It's basically a transformer with a bridge rectifier inside, a diode pack, and that's it. Non-regulated, linear power supply. We ran one per lane because of voltage drop and so forth. And that's how we got the old lap timer to work with it without it going haywire. And I do have a bunch of these on hand. They do still all work. I don't believe I'm gonna ever hook the track back up to these, but you never know down the road. Who knows? But I do have one of these that is currently on the track, powering the skid pad and just the skid pad, and it's powering all four lanes. And what controls the skid pad down here on the driver's station panel, the two steering wheel controllers from the old model motoring days. These are the ones that have direction reversing capabilities. And the bottom one controls the two outer lanes, and the top one controls the two inner lanes. So they're wired together. So party trick is you can run the inner lanes opposite of the outer lanes as far as direction if you wanted to. I did share a short video of that a while back. Kind of neat. But that's the only thing that's ever going to probably see that old school power supply on it, because it's just a party trick. It's not for serious racing, it's just for fun. Okay, so here we are back at it. Going to show you the underpinnings of the track. This is the main power supply that I'm using right now. It's a Womp Tech or something like that. 30 volt adjustable up to 10 amp capability. It's a bench power supply, regulated switching power supply. This is what the club recommends to use now. So we've gone to that standard, and it's basically screwed to the bottom of the track using one of those micro PC mounting brackets for under desk. And it is wired to terminal block positive, terminal block negative, 1-to-1 with a jumper. Make all four of these the same voltage. Runs out to a fuse box, 5 amp fuses, positive side out to a relay block that is controlled by an Arduino Mega 2536, which is basically operated by the race coordinator software on the PC. These are wired for normally closed, so that when the software is not in use, the power will continuously run to the track and allow you to run laps and not have to worry about the computer being on. From this point on, it runs out to another terminal block, which, as you can see, it looks like a lot of spaghetti from here, but I do know how it's wired. Basically from there it goes to the backside of the driver station panels. Driver station panels run back out and run over to another set of terminal blocks, one here and another one way down there, and those feed out to the 5 points on the track where the terminal tracks are to feed power. The rest of the system is basically to do with lap timing. There's our Arduino Mega. That little guy that's blinking away is a Bluetooth module. The laptop connects via Bluetooth to the Arduino. Less interference that way from the cars if we're going Bluetooth, right? Wireless. And that basically is the modern setup. This is pretty much, the power wiring is pretty much old school except for the relay and the Arduino. And other than that, we just have a surge protector down here that everything is plugged into. Cord goes up to the ceiling and up and over to keep people from tripping on it. The rest of this has to do with the second monitor, powering the Arduino, powering the main power relay board, and also the trip relays, which I'll get into well up under here. Okay, lap counter timing. Donnybrooke back in the day originally had what was known as a dead strip track, which is this guy right here. You can kind of see the marks here. There's a cut here and a cut here. It's about 3.5 inches distance where these two rails are isolated from voltage from these two rails. And what is done to continue power is underneath there is a wire that jumpers from here to here, here to here, and that's replicated 4 times for each lane. Underneath there are 2 wires per lane off of these that go down through the table, and right now they pass under the table into a terminal block, which when we're under the table, as when we were under the table, we'll show you how that went. And from the terminal block they come out to a pair of switches here that are 4-pole double throw, basically an on-on switch designed to reverse polarity of these 2 sections of the rail, this way or this way. Reason being, we have the lane reverse polarity switches to change direction on the track. I was under the assumption that I would need that to make the trip relays that trip the Arduino so it would be done correctly. A couple of times I have forgotten to throw the switches, and I have found that it doesn't seem to matter what polarity they're in, although in theory polarity should matter to make it trip more reliably. So that is the dead strip. Back in the day, this section would have been powered from the track power supply, but isolated from. So more accurately, in the day, this would have been considered a trip track, not a dead strip track. So it accomplishes the same thing, but in a different way. Continuing with lap timing, this is a predecessor to what we would have used. This is an Aurora model motoring electric lap counter. Basically works pretty much identical to the one we used to use on the track. Although the one we used to use on the track was more reliable, it was more of an instrumentation. I just have this here for display, but what you'll see here is an Aurora terminal strip track, but if you look closely, you'll see the ends of the track do not go through and make a connection. So it's an isolated track, or a trip track. And the way they did that, I have a copy of the Aurora instructions of the way they wired it. Yes, Christmas wrapping paper with cars. And the way they did it was with the standard power supply. Basically, your positive went to your positive rails, and then your negative side fed back to your two terminals on the back of the lap counter, and the return negative went back to the power supply. And at this point also it fed out to the main power terminal track, or tracks if you had many terminal track points for a large track, which I'll get into in a bit. And basically what it did was, this being powered but isolated, when the car went from the regular track and coasted over this, the car was still powered, but it completed the circuit. And when it completed the circuit, it would send the voltage to tell it to trip the lap counter, these guys here, and it would advance the lap. And it didn't seem to matter the polarity of it, as I had wired these up briefly to try them. They do function. Essentially it's just a solenoid inside with again a capacitor on it to help tame the voltage, and anytime it gets enough voltage to pull the solenoid down, it works the mechanical mechanism to rotate your numbers. So that would have been the predecessor to this guy here, but this works on the same principle, and that's how we would have had this wired up, same way. This is basically a replica of a TCP, or Tom Coy Products lap counter, more professional than the Aurora one, a little more accurate. And as you can see, it does up to 3 digits on the counter. So if you were doing 150 laps or more, well, technically you could do 999 before it would flip over back to zeros, but whereas the others would go to 99, and then you'd have to have somebody counting if you went past the 99 to go, oh, okay, that's 112 or something. But anyway, that's how they did it back in the day. And we're back with another thing on going to the more modern era in just a minute. Again, lap timing and well, in this case, heat timing and lap counting. This is what we would have used back in the day. These are electromechanical counters with a capacitor in circuit on these in order to act like a buffer to help tame the number of times it senses a trip, to keep the lane count, lap count accurate. And a simple darkroom photo enlarger timer, where we would set our heat for, say, 6 minutes, and you set it to the time. Focus would be to allow it to run all the time, and then you just turned it on, and when it got to the end, it would automatically shut the power strip off that all the power supplies were hooked into on the track. Very simple. And basically back then, all we were concerned about was total number of laps done. And I'll show you how we accomplished that in just a second here. So we're back to the track, and you may notice there are numbers on certain areas of the track. Now I have them running, so we have 1, 2, etc. in a clockwise for clockwise racing, and you may notice over here we have a 7. Back to here we have an 8. Up on the main straight we have a 9. Those are section numbers, and what that was done for was when the heat ended, it was however many laps were recorded and whatever section you ended up on. So if you were between 1 and 2, that counted as section 1. If you were like just at 2 or almost 3, we would consider that 3. The reason for that that system was used was for basically tie breaking at the end of the race when all the heats were done, and basically we just recorded it on a sheet of paper on a clipboard, and that's how it was done. So continuing on with the subject of lap counters and what we used to use, or what we would have used, we would have had a timing system on a computer like this. This is part of my vintage collection. This is a 1985 IBM PC Junior, fully functioning. Been upgraded with a Gotek drive to make it easier to get software on. And it has expanded memory card, parallel port, and this card is called a Junior IDE. It is an interface card that has a piggybacked on sound card that emulates a Sound Blaster card to give it full sound. And the IDE card allows interface to either a hard drive or a compact flash card emulating a hard drive. In this case, we have a compact flash card. So I'm going to turn this sucker on. Again, sorry for the camera work, guys. I am on my phone. We have the fabulous IBM boot screen. This will take a minute or so. We'll let it go through the process just for, nostalgia's sake. And this is going to boot off of the compact flash card. It is basically the C drive, something the PC Junior natively did not come with or could originally handle with the particular DOS version that it had. This particular one I'm running PC DOS 3.3. Seems to work fine with the handling hard drive capabilities. And in a minute here it'll go through its boot routine. The Junior IDE card also has capability up to I think it's 576 kilobytes of RAM. You heard me right, kilobytes. This machine has a total of 600 kilobytes of extended RAM. It is an 8-bit machine. Okay, so now we're at the C prompt. So this is running DOS 3.3, as I said. Or excuse me, 3.1. No, I'm sorry. That is the config version is 3.1. This is DOS 3.3. So I know there's another directory we need to get to. So we'll try to do this one-handed. This is going to be a little tough. And it was a program called Slot Race Manager. And if we do a directory, there's a whole mess of files on there. But the one that we're mainly interested in, once we get to the end there, just below we says startup, you see srm.exe. That's the executable file we want. And it takes a little bit to go through the memory the first time you do a directory on the Junior IDE interface. So we type srm to launch it. Slot Race Manager 2.53, last updated in 2011. It does have a something to do with the reset parallel port. Has a bad file. I think that's because I don't have anything currently connected to the parallel port. I could be mistaken. So we hit any key to start, and this I configured about a week or so ago. This is a recent addition. I've been looking for a copy for a DOS computer for a while. I may use this with Donnybrooke as just a kind of a whim, not serious with it. But as you can see, Slot Race Manager, Donnybrooke Park. It's got the owner is me. You could do single race, you could do a championship. There's all kinds of configuration menus you can go to, settings and so forth. You basically set up the scale of the track, the units it's in, how many cars, how many drivers, how many lanes, etc. The lane colors. I believe this was written by a fellow that goes by Cenobite, and he's from the Netherlands. I don't believe he supports this anymore. I found this online through a link through one of the slot car forums talking about this, and pretty much I don't think anybody uses this anymore, but this would have been something like what we would have used in the day. We'll just do a quick practice, and we'll start race with these settings. You can kind of get an idea of what it would look like. Yeah, it is an 8-bit machine, and yeah, it does take a little time, but this is what we would have used if on the track if we had kept the track going past the time frame that we did. As I said in the previous portion of the video, it's looking for something for a time core module, so it's going to time out on us, I think. The other thing is the PC Junior does not have a built-in clock, but however, there is a real-time clock on the Junior IDE board. No lap or race times to report. Okay, so it's going to basically make us go back. So we'll go to the previous screen. Oops. I think all we have to do is hit P. We don't have to hit enter, because enter will just bring us back. Okay. And that's basically what the idea of what we would have used after the electromechanical setup. If we'd have kept going with this type of thing, probably would have gotten a cheap DOS PC like this and some piece of software like this, which would have evolved into what's being used on the track now, which I will get into in just a few minutes. So hope you enjoyed this portion, guys, and we'll be back in a couple minutes. Okay, here's a weird one for you. I found this on eBay. It does work. What this is, matter of fact, let me turn it on. What this is this is a personal lap timer encounter. I believe this was intended for commercial tracks, for the big scale stuff. But essentially, this would work with the track here if I hooked it up. You got your two alligator clips. These would connect to the isolated section of the dead strip track. This guy would plug into this guy here, and as the car would go over, it would record a lap and how fast it was going. There's a microprocessor inside. I had never seen one before. It was called Lap Master by Fast Lap Racing Products. It appears to have been made sometime in the 1990s. And I believe it used to belong to a guy named Big Leo Winters at one point. So Big Leo, if you're still out there, I got your Lap Master now. Reach out to me. Let me know how you liked it, if it worked for you. Kind of a neat thing. It's in its original box. Kind of got it as a collector's piece. I don't have any intention of really testing it with the track, But apparently they also had a version that could have had a printer interface with it. This one does not. So you could have printed out your lap times, I guess. So let me know in the comments if anybody's ever seen one of these before. I hadn't. I thought it was kind of neat. Runs on a 9-volt battery, and I just keep it around because it's kind of cool. Okay, while we're under here, these are the wires that come from the dead strip track. The isolated portion runs into a terminal block, and then it runs out to that switch I showed you earlier on the other side of this panel here, and back, and it runs up to this terminal block here. And it's at this point that I was hoping to be able to power both the trip relays and wire in the old school lap counter. And upon trying to do that in various forms, I kept finding it would function briefly, but would constantly trip the power supply's overcurrent. And it wasn't liking it. In the old days when we just had power supply like that, it didn't care. It just went, oh, shocking, but okay, and just kept on taking it. Well, we've gotten to more modern, and well, probably not best for those old power supplies either, but it just went with it. The new power supply you see hanging over there would just go into overcurrent, trip briefly, shut the track down until it reset, and it just wasn't having it. So what I've done is we just left the modern equivalent in. Basically these wires go down, feed into 4 individual optocoupler isolation trip relays. They're powered by 5 volts, as you see. So the trips go in here. Every time a car goes over it, the car goes over the rail, and it sends a pulse signal, which could be as high as 18 volts. I haven't measured it, but the reason for the optocoupler is so that that higher voltage does not go into the Arduino. Higher than 5 volts into an Arduino is a big no-no. They don't like it. They have a tendency to do things like fry, and we don't want to do that. Yet, even though they are expensive, we just don't want to do that. So the other side, so what happens is when the pulse comes in, the optocoupler senses it and it trips this relay, which is in the normally open position. And when it trips, it closes it. When it closes it, it sends a pulse back over to the Arduino. The Arduino tells the computer, hey, there's a car going over, there's a lap, start the timer. And when it catches the signal the next time, it counts as another lap, and it gives you your time in between, which is your lap time. Back in the day, we weren't so concerned about that, but apparently nowadays we are. So, but this is the timing system from underneath. You know, just a little overview of that. And how I wired this, I'll show you in just a minute. We'll be back after a jump cut. One additional thing about the race coordinator and the Arduino, this beehive looking thing with the red button on it right here, that is our master track call button. If you want to understand, the club does not use anything like that. They just use the space bar on the computer. This does the same thing. So it's there if it needs to be. And this is the back side of the monitor that the drivers can see from the driver's station. It's just a basically dual monitor setup used on the laptop. And this is a 3D printed item I found, and worked out well. All the brackets for everything I talked about underneath for the Arduino and the trip relays and the master relay, all the brackets are 3D printed. I found files on thingiverse.com and printed them out on my 3D printer. And a lot of you may know what this is. This is a Windows 10 HP notebook computer. probably about 5 years old. But race coordinator software seems to be the popular thing. A lot of people have been asking in the club, why did I go with race coordinator? It is an approved software that they do allow to use. They seem to prefer TrackMate. I didn't go with the TrackMate software or the TrackMate system just because of, well, let's face it, cost. It's like a $300 system by the time you're done. This software is a free download, although I understand the TrackMate software is a free download. But the lap timing system, the light bridge and the sensors and the TrackMate interface box and the wiring, it's all like $300. The Arduino, the Mega 2536, I had one already, but I think it was like $26 at the time, and it's a genuine Arduino, not a knockoff. The Bluetooth board was $7.99. The 4 optocoupler trip relays, I think, were $8 for all 4. And I think the power supply trip relay board, I think, was also $8. The rest of it was just all wiring it up. I think the most I spent on the system for that, to do with the lap timing counting, was the switch for the track call, which it's actually the only TrackMate product on the whole thing, from what I understand. And I think I paid like $14 for that. So do the math. It's a lot cheaper. It doesn't take much to set up an Arduino, and it does seem to work reliably. And as far as the dead strip track, working with it, it works fine with the method I'm using. I found the method on I think it was slotracerforum.com, one of those that I'm a member of, and it was just pretty straightforward, and it was cheap, and it worked. And you know, so this is what we're going to be using on it from now on. If the track was in continuous use all these years, these other upgrades would have been done eventually. The modern power supply, this timing system, etc. Would we have gone to routed track? Possibly, but routed track is not cheap to make either. So this again was more of a restoration project of what was, and trying to integrate a few modern things to appease the club to come back and use the track again. Again, that club was MARC Northeast, or New England Miniature Auto Racing Club. They are affiliated with HOPRA, HO Professional Racing Association, and which is kind of a big deal, because back when it started, it was just a couple of guys that had a couple of their buddies together and didn't always want to go to one track, so we got another track. And well, 40-something years later, here we are. Okay, guys, this is the example of how I figured out how to wire up the track. This has been on the internet for a long time. Fairly easy to find. It's a couple of different diagrams, but this is essentially how it is. The power taps for each section of the track, it's all in parallel. Runs over to each of the driver stations, and that's the only thing I don't have hooked up, like I show in this illustration, is a brake defeat switch. The brake is just wired, you know, constantly. We used to do a brake defeat switch in our controllers, and I can show you one of those in a bit. But that's the way the track is basically wired. And to show the driver's station panels, we have direction reversing switch, brake, wiper, power. We have basically old school Parma economy. These are 45 ohm resistor controllers. These do have a heat sink in them. It does fit inside the case. The binding post will work with alligator clip, or in this case banana jack. When these came on these controllers this way, when I got them secondhand. And this one is wired to basically these three. It's a 1/4-inch stereo phono jack, and it's wired in such a way like the Scalextric standard is, from what I understand. That's the way we used to do it. I'm finding with using the old controllers that are wired that way, if you plug them in while the power's on, it's not such a big deal, but if you pull them out while the power's on, it causes a momentary short circuit, and it trips the power supply into overcurrent briefly. It doesn't like it, so this is pretty much why I think they've gotten away from that standard, and it really wasn't a standard either. All across the world, there's all kinds of different connection methods that people use for driver stations, but here in the United States, the 3 binding posts is the most common. But with these being basically instrument binding posts, it allows you to hook up banana jack or alligator clip. And that's pretty much that. And the polarity reversing switch for reversing direction, the way I understand the wiring, it basically switches the polarity of the wiper and the positive, so that it changes your positive rail on your track from here to here, and you're going clockwise or counterclockwise. Okay, guys, here's my new to, well, actually it is new, we'll call it a pit box. This is actually a machinist type toolbox. This is a Harbor Freight purchase, so it's not very expensive. I wasn't going to spend the, I don't know, $700+ that they get for the real deal ones, but you know, this was like $89.95. It's an all wood box. Slides under. You got the drawers. We got our Aurora drawer. We got our Tyco drawer. We've got our AMRAC drawer. And as those you may recall, AMRAC started off as Cox, C-O-X, became AMRAC, became Rollcore, and I believe now they're Lifelike. These are the early chassis that are very similar to the Aurora AFX G Plus chassis. Used to be able to get these at like KB Toy and Hobby for like $9 or something, $9.99 if I remember right. And the Tyco 440s were like 18 at the time, if I remember right. But anyway, we have some old school resistor controllers here. We've got basically a totally stock 25 ohm. It's the next model up. It's not a turbo, but it's not an economy. It's the model in between. It's a single resistor. We have an old Rust kit that's been modified with heatsink and the switch for the brake defeat. And this one is, I believe, about 12 or 13 ohm. This was my uncle's. He used to run this with his modified car. He still has that modified car. He's raring to go up, bring it, and use it again on the track, just to see if it still got it and if he still got it. This is a Parma economy controller. This is a 35 ohm. Recently rewired, and I did do the stereo jack, and it has the brake defeat switch in it. 35 ohm, and it does have heatsink in it. Again, this is another 25 ohm. This one has been modified for the brake defeat. These two were my uncle's best friends when they had a racing team together, doing this with the club in the early days. His name was Steve. He had a bunch of interesting ideas for his controllers, and I believe, as I was told, it was a lot of these ideas were just done to psych people out. We're talking like the gauge of the cable on these things. When I first got a hold of these things were like ridiculously huge wire size, way overkill. And basically, I think it was just done to psych people out. Like, whoa, if that's what he's using, that's got to be, oh, we got to be so much faster that way. That's his secret. No, it was just done to play mind games. But there's a new pit box. I don't think I'm going to mar it up with stickers and decals and stuff. Although that's what everybody used to do back in the day. It's just too nice looking to bother to do that. And this sucker's going to be pretty heavy if I take it anywhere out of the basement here and bring it to an actual event. People may be asking, oh, why don't you have a DeFalco or one of the newer electronic controllers? To me, doing that's like reinventing the wheel. These Parma controllers with the resistors in them, these were the hot setup in the day. They still work. They just work. You don't need all those extra dials and stuff. If you learn to drive the car properly, you don't need all that extra stuff. You know, controllers these days with all the bells and whistles, the electronic ones, starting at $90 and working their way all the way to $475 I've seen for certain ones. Why? You just reinvented the wheel. These Parma controllers, I bought all 4 of these secondhand. They're all 45 ohm, which is about right for the older cars that I'm planning on using with it, with the track. And it was $60 for all 4. You can buy a brand new Parma from Mid-America Raceway, averaging on an economy for like $35, I think, plus shipping. They work. Why reinvent the wheel? These are a step up. Again, sorry for the camera work, guys. I'm on the phone. These are a step up from these Aurora controller pluses. As you can see, they're kind of small. They're probably teenage size, young adult size, not full-grown adult size like the Parma ones are. The party trick of these is these are supposed to be adjustable sensitivity, which means variable resistance. I've tried them. I don't see much difference when you're tweaking with it. And these get hot. The resistors in these are pretty small. It's basically the standard resistors in the old Aurora, quote, rust kit style hand controllers. So these I bought. I tried them. I may keep them around. I may sell them off. I'm not sure. They've got alligator clips on them for now, so they'll work with anything. But they're supposed to be adjustable. I've read anywhere from 12 ohm to 45 ohm. I've read 35 ohm to 70 ohm. There's conflicting information. So I'm not 100% sure, but that's what those are. And yeah, so reinventing the wheel? I don't think so. Will I be able to use these on some of the tracks the club uses? Possibly. If I adapted them to have alligator clips, or did an adapter for one of the other ones with the lower ohms ratings where it plugged into a stereo jack and came off as alligator clips, I am planning on making up a few of those adapters. But, maybe laughed at, gone, oh, you got to get rid of that, Grandpa. Although all these guys that are running in this club are still about 20 years older than me. I'm in my mid-50s now, and these guys are, well, yeah, late 60s, 70s, a couple of them in their 80s. They're not going to be around forever, but they want new blood in the hobby. And I get that. But I know people keep going, oh, another scenery one. Yeah, well, I did some more scenery. There's the latest edition. That is another footbridge, printed in 3D printed in white, and we have the Donnybrooke Motorsport Park logo on the bridge. I felt the track needed its own logo on the track, and we've got some more trees, some more hay bales, and think everything else is pretty much the same. Flagpoles have been added to the back of the original grandstand. Come to find out, this is an Atlas grandstand that is supposed to have a roof on it. Well, my uncle never remembered having a roof on it, so somebody must have gave it to him like that. And so part of it's missing. Not planning on replicating it. The flagpoles look fine. So, and we're over to 3 Quonset hut garages. As I said, the fire station has gone away. It is going to be used with our train set that we set up around our Christmas tree at Christmas time. So, Craig, sorry it's not on the track, but it just doesn't look right on the track. It's too big, and it doesn't go with it. But we do have the B-29 you gave me hanging down here. So we got the Air Force looking out for us. Alright guys, I think that's going to do it for this one. Once I edit this all together, this is going to be a pretty long one for a change. And hopefully we're going to be getting to doing some racing soon. My plan is to maybe record some practice sessions with the webcam there in the corner. It gives you a good vantage of the whole track. And in lieu of that, possibly some live stream events in the future. So that's going to probably be it for now. Hi guys, Goggles here again. Almost forgot one last final thing. People were wondering why a dead strip track instead of light bridge and photo sensors or Hall effect sensors. Well, the track originally had the dead strip track, and it's on a 15-inch straight section of the old Aurora model motoring lock and pin style track. Something I probably should have mentioned before. That's what this whole track is 1960s Aurora model motoring lock and pin plastic track. Well, the 15-inch sections were pretty rare, as it turns out. Hard to find, very expensive when you do find them, and I wasn't about to hack up another set of tracks just to put in some light sensors or some Hall effect sensors. Could I have done it on a 9-inch section? Probably, but it wouldn't have put it in the right spot in the where the track is laid out. So I opted for dead strip to stay. Dead strips are pretty reliable. It was already there, and it was pretty simple to integrate it with the Arduino, and it seems to work very reliably. I haven't had a car miss a trip on it yet. I don't have any cars that are super fast like today's Viper chassis or Mega G Plus or any of those. So we'll have to see what one of those will do. But I think mainly on this track we're going to be running old school cars for like IROC type of events. Not for any points, nothing serious. And that's the reason behind the dead strip track. Do I recommend it for everybody? I can't say that for sure. It works for us. It may work for you if you understand the theory behind it. So it's up to you guys how you build your track as far as I'm concerned. If you're building it for certain rules within a certain club you're planning on using it with, check with them first. I had a lot of people that were like, oh, we don't use that anymore. Doesn't work reliably, this, that, the other thing. Well, I hate to contradict them, but in this case, it seems to work more reliably than the TrackMate system does. So, anyway, that's where we're at with that. And it's a long one when I get it all edited together, but you know, sometimes you got to go with a long one to get all the information. We'll catch you next time. And until then, keep it in the slot.